I'm Judy Hill from Lawrence Livermore National Laboratory, and I am very privileged to chair the session on the Fred Howes Scholar in Computational Science. The Frederick A. Howes Scholar in Computational Science Award was established in remembrance of the late Frederick Anthony Howes, who managed the DOE's Applied Mathematical Sciences program during the 1990s. Dr. Howes was highly respected and admired for his energy, dedication, and personal integrity. To honor Dr. Howes' memory and his commitment to the CSGF program, 1 or 2 alumni is chosen each calendar year as a Howes Scholar. This award is bestowed upon a recent graduate of the DOE CSGF program who has shown outstanding leadership, character, and technical achievement in the field of computational science. It includes a substantial cash award, a crystal paperweight, and the distinction of being named a Howes Scholar. Before I introduce our 2024 Howes Scholars, I do want to acknowledge Mary Hall, who is in the audience with them. Mary was Fred Howes' wife and a generous supporter of the Fred Howes Scholar. Let's thank Mary. As a past recipient of the Howes Scholar Award and the current award chair, I am honored to recognize and introduce our 34th and 35th Howes Scholars, Kyle Bushick and Quentarius Moore. Let's recognize them. I am pleased to name Dr. Kyle Bushick as a 2024 Frederick Howes Scholar in Computational Science. Kyle completed his PhD in Materials Science and Engineering in 2023 at the University of Michigan under the supervision of Professor Kiopakis. After graduation, Kyle joined Lawrence Livermore National Laboratory as a postdoctoral researcher. Kyle's selection as a Howes Scholar reflects both his terrific research accomplishments and his stellar leadership and character. During his PhD, Kyle led breakthrough research in the use of atomistic simulation to understand the fundamentals of phonon-mediated quantum processes. A running theme throughout Kyle's research is the bridging of quantum mechanics and other fundamental physics with the practical study of technologically relevant materials. Kyle's contributions spanning physical theory, applied mathematics, and software development enabled the first use of modern high-performance computers to study the critical role that phonons play in Meitner-Auger recombination. Kyle also made important contributions to the modeling of optical properties of boron arsenide, leading to impactful collaborations with experimental research groups across the country. During his PhD, Kyle led or contributed to 11 peer-reviewed manuscripts. His technical accomplishments have important engineering implications in a broad range of application areas, including the development of higher efficiency photovoltaics. Separately, though, Kyle has also demonstrated exceptional leadership and character with wide-ranging impact as a champion of inclusivity and as a builder of community. A running theme throughout Kyle's service activities is the bridging of previously unconnected or underconnected research groups. Kyle served as the president of the University of Michigan MSc Materials Science and Engineering Graduate Student Council from 2021 to 22. His core achievements in this role included successfully advocating for graduate student participation in the department chair hiring process, leading a department-wide survey on the graduate student experience, and organizing numerous social and professional development events for graduate students in the wake of the coronavirus pandemic. Kyle also served as the co-coordinator of the highly interdisciplinary Michigan State University of Michigan-wide Sustainability and Environmental Workshop. Kyle also distinguished himself by dramatically expanding his department's graduate student STEM outreach program, establishing new relationships with local partner organizations in schools, museums, and libraries, and spreading the joy of science, especially in traditionally underserved communities. These relationships have continued growing beyond Kyle's time at the University of Michigan, a testament to his vision and enduring impact in the community. Dr. Kyle Bushick is a role model for others as a computational scientist and as a leader by example. He embodies the qualities of technical strength and strength of character that Fred Howes encouraged in all early career scientists. Let's recognize Kyle. I'm also pleased to introduce Dr. Quentarius Moore as our second 2024 Frederick House Scholar in Computational Science. Quentarius completed his PhD in chemistry in 2023 at Texas A&M, where he was advised by Professor James Batias. Following graduation, Quentarius joined the High-Performance Computing Applications team at Advanced Micro Devices, AMD, where he is presently a member of technical staff. Quentarius has been selected as a House Scholar due to his outstanding research achievements and his demonstrated leadership and character. Quentarius has substantially advanced our understanding of how mechanical distortions affect the chemical reactivity of two-dimensional materials, for example, graphene. This field, mechanochemistry, promises substantial societal impacts, including low-cost, environmentally friendly chemical synthesis. His research stands out for its close collaboration with experimental scientists. For instance, by developing ways to use density functional theory in the context of graphene under strain, he revealed how even small strains can dramatically alter chemical reactivity. His computational contributions enabled the first direct comparisons to experiments and the development of new experimental methods. During 2 summer practicums at Sandia National Laboratories, he studied strain effects on single-layer molybdenum sulfide deposited on gold surfaces, yielding a paper in ACS Nano. Quentarius also completed an internship with the HPC applications team at AMD, where he was assigned what his mentor describes as, and I like this, quote, a Hail Mary effort to port the quantum chemistry code Quantum Espresso to AMD's graphics processing units, GPUs. After achieving this Herculean task during his internship, he also optimized this code for the newest AMD GPUs on the Oak Ridge Frontier supercomputer, yielding long-lasting impacts on other AMD HPC efforts. Quentarius also demonstrated leadership and character throughout graduate school. He served as a leader for outreach and community engagement in the local chapter of the National Organization for the Professional Advancement of Black Chemists and Chemical Engineers. When the National Science Foundation awarded Texas A&M the Center for the Mechanical Control of Chemistry, Quentarius led a major outreach effort by initiating the center's YouTube channel, creating a global online seminar about mechanochemistry. Quentarius also recruited and trained other students to maintain continuity for these online outreach efforts. Among his peers, both in his advisors group and throughout the department, Quentarius developed a reputation as the go-to person for anyone who was facing difficulties and wanted advice. His contributions went far beyond service in professional settings. During his PhD, he volunteered at several nonprofits around the Texas A&M campus, focusing on supporting the College Station community. In one of these, a K-12 after-school program, he organized a weekly chess program for students, serving at once as a teacher, a coach, a mentor, and a role model. Dr. Quentarius Moore has made substantial and varied contributions across his communities, demonstrating initiative and courage in addressing challenges. He exemplifies the kind of scientific excellence and leadership that Fred House encouraged in all young scientists. Let's recognize Quentarius Moore.